So skill 16 was solving quadratic systems, and basically the main objective of this skill was to determine intersection points algebraically. So I chose my a value to be 5, b equals 16, c equals 8, and d equals 4. And basically we had two equations given to us where we just had to plug in the a, b, c, d values, and essentially we had to calculate the intersection points by hand. So first, I added, since they're both equal to 1, I added this equation to this equation and then moved the 1 over to the other side by just adding 1. So then this plus this equaled 2. And then this y, or the second part of both equations, ended up canceling out. So I had x minus 5 over 16 whole squared plus x plus 4 over 6 whole squared equals 2. And now this next step here just shows the foiling of the numerators and writing their denominators in squared form. So I just did x, so this is like the expanded version of x minus 5 squared, and then this is 16 squared, and then this is again the expanded value of x plus 4 squared, and then this is 6 squared, and that equals 2. So next, I wanted to add the fractions together. So for that, I had to find the least common multiple, and that was 2,304 for me. So then I essentially multiplied the numerator and the denominator by 9 for this first fraction, and for the second fraction, I multiplied it by 64 on both the top and the bottom. So this kind of shows the 2 steps into one about adding the fractions together. And now the next step I did was that I multiplied this side by 2,304, and same thing I did on the right side. And I also distributed the 9 to these 3 terms and the 64 to these 3 terms. I then combined like terms, and I set it equal to 4,608. And then I moved 4,608 to the other side and set it equal to 0, so this would be in the quadratic form. And then I used Wolfram Alpha, or you could also use the quadratic formula, and I got x equals negative 10.264 and x equals 4.4831. So now what you would do is that to calculate the intersection points algebraically, you would plug in both x's to both of the equations. So as you see, I plugged in the x value, the negative 10.26 value, into this first equation as shown here, and I got a y value. And I did the same thing to the second equation, and I got another y value. And then I took the next x value, which was 4.48. I plugged it into, again, the first equation, and I plugged it into the second equation. Now I did the calculation in my calculator, but here just shows how I would solve that algebraically. And so then this y value would be the coordinate that you would get. So I had 4 intersection points. You had to have, I think, 3 or more. And so my first intersection point would be, the negative 10.264, which is the x value I plugged in, comma, negative 6.8. Then the second intersection value would be negative 10.264, comma, negative 9.2. Similarly, these two intersections point would be 4.48, which was my x value I got, and when I plugged it in, I got negative 4.002, and then here it'd be 4.48, comma, negative 12. And then here I wrote down the intersection points according to Desmos, and as you can see, they match up. Negative 6.8, negative 9.199, I rounded it to negative 9.2 when I solved it algebraically. And then, so as you can see, I checked my work, so when I went to Desmos and I looked at the intersection points, they matched up to what I had algebraically. So this was skill 16.